Hey, it's good to be here, back on campus where it all began. And I want to give everybody who doesn't know about us a little bit of a kind of a flavour of who Salsa Sound are, what our background is. But then specifically, we want to talk about AI-driven mixing for live sports, because that's basically what we do. So background to us, like Ben said, Salsa Sound came out of a research project, like back in 2010, maybe 20 something, which was an EU project, and we were looking at interactive broadcasting. And long story short, we then developed a load of tools that enabled us to do live object-based segmentation, which would facilitate the interactive broadcasting. But importantly, also, we realized helped facilitate current mixing paradigms. So using kind of audio pattern recognition to kind of automate a mix that was going out in current linear live TV workflows. And that's where we realized, actually, you know what, this is a good business proposition. So a few years later, we founded Salsa Sound and have been selling our technology to broadcasters around the world, helping them make content that better engages with fans and helps them do more for less, like automating some procedures. So deep down, we're all about interactive broadcasting, we're all about object-based audio and immersive, and we specialize in live sports. So when you want to do the audio for live sports, it's really about telling the story. It's about telling the story of the event that's unfolding in front of you. And any story obviously has what am I trying to say? Has like a narrative, has and on diegetic sounds, and it's also got a score which has got the emotion. And live sports is exactly the same. You need to have the on-field sounds give you that kind of the narrative of the event, and then the crowd in the stands give you the score, give you the emotion. And we all saw, like during COVID, when the sports went behind closed doors, that all of a sudden the emotion went out. I don't know if you were like me, but when everything came back online, I was watching Match of the Day thinking, phew, I'm back. Like, this is the sport that I know and love. So these two things always keep in front and center, that we want to make sure we capture the crowd immersively and with the right dynamics, but that we also capture all those diegetic pitch sounds. But when you're talking about live sports, a live broadcast, it's not quite so easy, and maybe you have to sort of like throw away some of your aspirations of doing perfect Hollywood style storytelling, because it's live, it's unpredictable, things happen really, really fast. It's not always possible to put microphones somewhere where you would ideally like it. You can't run around a jockey with a microphone trying to capture the sound of the hooves. You are restricted in what setup that you've got. And if we miss the sounds, we're missing part of the story, but that's just what kind of tends to happen in a live environment. Also, if you've ever been to an outside broadcast, mixing the sound is just one of a gazillion tasks that the audio guy is having to do. So managing all of the comms network, he's setting up everything, doing the fact check between the microphones and doing all the processing, setting up the consoles and talking to the other people on set. So there's a lot of stuff going on. And then you've got your production cut, but then what about the audio that goes with the replays or special camera cuts and slow-mos and things like that? So it's a big job, and in a live context, really, really difficult. So anything that we can do to make life a little bit easier, that's what we're all about. So put this slide in. This is an example, just to give you a flavour of how things are done currently for football. As you might not necessarily know. This is friend Ian mixing a match on the right-hand side, and he's got access to, 12 microphones around the field. So this is pretty much how it's done across Europe. This is kind of very standard mic setup. Now, naively, you could think, oh, just put all the microphones into the mix and then you'll capture all of the sounds on the pitch, but that doesn't happen. What happens is the sound of the ball being kicked on one side of the pitch is masked by the 70,000 fans around the field. So he's meticulously working there to make sure that only one microphone's ever in the mix, or one or two at any one time, so that as the ball goes near this microphone, you raise that in and you make sure you capture those sounds of the players shouting at each other and the kicks and things like that. So it's like playing the piano. So you can imagine having to do that. It's cognitively very expensive task that just occupies the mix's attention for the entirety of the game. And when you've got all, like I say, the comms and then monitoring maybe different flavors, different immersive mixes, there's a lot going on. And so this is where I think it's useful for us as kind of audio researchers to think about how does our research impact what people are doing in a real environment. And we'll talk a little bit more about that later. It's very similar out in the States as well, how they do things. So this is the same problems really in terms of catching the on-pitch sounds. So this is an American football match, and they use parabolic microphones there. So really ridiculously directional microphones that even if you point at something, you hear it. If you move it even just like 5 degrees off axis, you can barely hear it. So they'll have 5 operators around the field, all kind of just pointing at the action, and then have somebody in here somewhere, probably that guy, who's doing a submix. He's mixing just those parabolic microphones to get all of the action on the field. And then Terry in the bottom right hand corner is managing the presentation mix. So all of a sudden, to mix one NFL game, you've got 5 guys around the field. You've got your 6th guy here. There's 7 audio people involved throughout the duration of it. So you can see there's not particularly efficient way of running things. And so that's where we've approached it, to use machine learning and AI to kind of help that along and kind of streamline things. Other kind of interesting things that happen in the sports world that maybe not everybody's totally aware of is augmenting sounds. There's a lot of kind of weird voodoo that goes on that you don't know about, maybe. So bottom right hand corner for rowing, can't put microphones on boats. You're not allowed to, certainly for the Olympics. You could probably do it in other sports, but you'd have to then get the RF signals off, and if they're going sort of 10 kilometers downriver, it's obviously really, really difficult to do that. So they have literally somebody with a MIDI keyboard triggering samples of people rowing, and apparently the sound of people rowing is too splashy in the broadcast, and some of the rowing coaches told them off because they're like, oh, our rowers shouldn't be making a splash sound, your broadcast is too splashy. So you've got to pick samples correctly. Put the gymnastics one up there because it's kind of interesting that this is all about kind of what people want to hear rather than what's necessarily going on. So if you stood next to this, what's it called? Hobble horse? Pommel horse, that's it, yeah. Weird, but that, you hear a little bit of the hand sounds, but you don't hear loads of action, and then you've got all the crowd sound drowning it all out, and it sounds a little bit mundane. So they put contact transducers in there, so you can hear all of the and the kind of squeaks and turns. So it's not reality in that you wouldn't hear that if you were stood next to it, but it's what the TV broadcasts come to expect. Similar thing with the skiing as to the rowing. Actually, that's quite a lot sample driven, and the darts. You don't really hear a dart go in, especially when you're in a massive pub, which is basically what darts is. So they use an accelerometer that triggers the sound of a bass drum. So you get this woof when they hit the dartboard. So I just put that in just for a little bit of interest. And obviously we've been talking a lot, we did a lot of work on virtual crowds during COVID, because all of a sudden with no crowd, there was no emotion. And so one of the sort of the pivots that Salsa Sound did was to produce an app that would allow content creators to create their virtual crowd sound that actually responded to the action on the picture easily. So we're kind of moving into this kind of, I'd call it real-time post-production, which is a bit of a oxymoron, but that's the way it is. So these guys are being asked to do more and more and more in less and less and less time and with less and less budgets, which is obviously a problem. And then everyone in this room probably loves a little bit of immersive audio and a bit of interactive audio and things like that. But imagine that on top of what everybody's already doing. So when we approached the industry, we were in a very much bullish mood about, wouldn't it be great if everything was object-based? Wouldn't it be amazing if everybody could interact with their own scenes and change different levels? And then you come up against the industry who's going, whoa, we're struggling to survive. Like, we're struggling to get something out on air. We've got like maybe 3 hours to set up and then it's got to go out to, 10 million viewers or something. We don't care about object-based audio. That's the kind of reaction. that you get, because there's a lot going on. There's actually, believe it or not, there's a big personnel shortage in the broadcast industry at the moment as well. So there's less people trying to do more for less in less time. So can AI, can machine learning, algorithmic mixing actually like add value here, help people out, make jobs easier, allow them to do more for less, and maybe not just maintain the status quo, but actually go one step better and start doing things that we weren't able to do before and create better experiences for viewers? That is what we're all about. And one of our kind of mantras is that microphones are not just sound capturing devices, they're data gatherers. You think about, we've got at a football game, for example, you might have upwards of 30 microphones, all of which are just capturing an enormous amount of data. And at the moment, we only use it for capturing the sound, so we can hear stuff. Clearly very important and the primary use of a microphone, but actually there's a lot more information in that audio, which using AI we can mine and then generate new experiences or kind of create metadata and maybe automate the production of highlights and things like that. So we'll talk about some of those opportunities later. So the way that we've approached it is looking at audio event classification, and because that's essentially what it's trying to do. When I showed you Ian in his truck raising and lowering the faders, what he's trying to do is pick out the sound of a kick, pick out the sound of a whistle, or the impact sound in American football or ice hockey, or you name it. They're trying to capture those specific events. So the way we've approached it is to use audio event classification to do that automatically. So you can go, hey, up, this microphone is the one that we want to add into the mix. This is where the sounds of interest are, the diegetic sounds, which add to the story. So for an ice hockey context, very similar kind of vibe. Apart from you probably don't need windshields on there, but hey, what can you do? There are obviously microphones around the rink. So the way that we apply this is all the microphones go into some kind of audio interface, and then we do real-time analysis that are listening out for those specific objects. And when it detects something of interest, like the sound of a puck, then it triggers an event, and it will then push that microphone into the mix. Obviously, there has to be a latency there, because you detect it, and then you have to then add a slightly delayed version of the microphone so that you actually pick up that mix, else you're just constantly chasing around and missing everything that you just detected. So there's a 40 millisecond latency, so it takes 40 milliseconds for the AI to detect the event, and then you add it into the mix. And you compose an output that hopefully contains all of those diegetic sounds that help tell the story of what's actually going on the rink or the pitch. So I'll hand over to Max, who's going to do the clever bit and just talk a little bit about how this works in real life.
Thanks.
Great.
So this is kind of like a standard AI workflow for us. So it's a two-stage approach. We've got the training first. So we're taking in kind of simulated live audio, so recordings, and then hours and hours of that, as much as we can get, more the better, hundreds of hours if we can. Tagging that, which takes ages because we have to do it by hand. So if we're going through trying to detect ball kicks, have to find all those ball kicks, tag them, and we can't leave any out, otherwise the network will know, it won't know what a ball kick is. Then we have the pre-processing, so that's kind of manipulating the data to get the best representation out of it, to help the neural net see kind of the features we want it to see, so that it can then go on and detect it, and then it trains the model, and we get that out. And then we've got our actual running of that model. So now we've got the live audio coming in, and that has to be pre-processed in the exact same way as before, so that the model gets the data kind of in the same format that it's been trained on. And then that, when the model will make a decision as to whether it's detected an event or not, and it will do whatever we want with it. So it might make a mixed decision, or it might kind of do some output some metadata, and that's kind of where the software kicks in. So there's a few things we can do to help the network, to kind of help it train the best it can. The most important thing is the data we give it. So we want to give it data that completely simulates the kind of place it's going to be used in the end. So those hours and hours of content, and it needs to be content from any situation that we're going to encounter in real life. So for us with football, we need to do multiple stadiums, multiple kind of levels of football with different crowds. We want to get a really useful representation of that data. So we want to kind of think about what we're trying to do and manipulate the data using DSP to help the neural net as much as possible. So if we're trying to detect a high frequency sound, we can take out, and we're going to pass the network like a Fourier transform, we can take out all the low frequencies because we know that it's not going to use them, and we don't want it to detect any kind of, we don't want it to pick up on any patterns which just aren't useful. Quite often with live audio, we're working with unbalanced data sets, because if you think we're trying to pick up something every 10 seconds on average, and we're running the network once a buffer, so like 40 times a second, we can have 99% negative samples and 1% positive. So the network will be able to kind of think it's doing really well because it will get like a 99% accuracy just by saying that everything is not the thing we're trying to detect. So you can kind of get around that by using different metrics. So you can, rather than looking at how many samples you detect correctly, you could look at how many positive samples you detected correctly, or like the percentage of positive samples compared to the percentage of negative samples. And that kind of feeds right into the optimization of the network. So you can take that metric and then look at it relative to itself when you change different parts of the network. So you can change the network size, or kind of how you're manipulating the data which you're putting into the network, see if it does better, and then you've got a better network, and then just keep doing that until you've got the best network which you can get. Is it down there? How do I
Just do it.
Oh. There we go. So the hardest thing for us is doing all of that in like the real-time space. So we might have to run that in 20 milliseconds on, like for the ice hockey, we might have 8 mics around the rink. So that's a huge amount of processing for a really short amount of time. And TensorFlow and PyTorch and kind of those other frameworks, which are for doing AI in general, aren't really built for this kind of high speed use case where you've got a certain amount of time, you've got a window of time, and you can't fall behind that. They do provide like C, C++ APIs. They're still not optimized for real-time use, but they are quicker. And it's a bit complicated because, so TensorFlow has like a C++ API just for running models. So you end up training the model in Python, running it in C++, and then you've got to kind of do all the pre-processing in Python and then reproduce that in C++. But even if you're doing the same processing blocks, you might have different algorithms which you've got to recreate so that you've got exactly the same output every time. So the network's getting the data which it expects. And actually a lot of these kind of use cases which we have aren't really needed in real time. I think there's a difference between real time running and kind of live running. So if we're doing speech to text, we can run that live, so we need the data quickly. We don't need it to make a mix decision or to kind of affect the audio, so it doesn't have to run in the audio thread. So you can kind of do it in a separate thread, run it a bit slower, but you don't clog up all your audio processing. It's really important to pre-filter the data. So if there's a way that you know, like a characteristic that's of something you're trying to detect, you can look for that characteristic. And it might not be enough to actually detect the event every time, but it's enough to kind of say, oh, well, this might be a kick, or this might be like an ice hockey hit, or it's definitely not. And then you might take your kind of 13 microphones, which are running the network on it, down to 5 or 6. So that can help a lot. And you've always got to have a backup. So because running the network is not like a deterministic thing, there's always a chance that you'll run over time. So you've got to kind of plan for that and have something which happens if you run over time, and because you can't have an audio glitch. So for us, if we're doing a detection, we just say the thing wasn't detected. But that could be you might have a more complicated solution to that. And yeah, there's always a trade-off between kind of the data size, the network size, and the speed of it. So if you're running on a huge network with lots of different representations of a sample, then it's going to take ages to run because it's way more like computations per like running the network. So that's going to take way longer, but you can reduce that and it might perform better, but at least you'll be able to do it in time, which is better. And that's back to you.
Thanks. All that is to say, it's difficult. Just to summarise those last few slides, and all of that optimization has taken us a lot of time, but we've approached it very much with an audio mixing kind of paradigm to start with. But actually, like I say, if we start thinking of microphones more as a data gatherer, as a sensor, then there's a whole ton of other options that we've got, some other possibilities of where this very similar technology could find a place in the real world. So some of the stuff that we've looked at in terms of automatically classifying microphones. So I said that only part of a sound engineer's job was actually mixing. Well, a big part of it's actually setting up the console in the first place. So how good would it be to have a kind of auto setup button that would kind of go, that is very similar. That's probably a pitch mic. This is probably a crowd mic. You should apply these, gain this compression, this EQ on, and sort of give people a standard starting point, and suggesting like audio processors specifically. Another big one is automatic QC and error detection. So there might be, if any broadcaster, they might be having kind of literally hundreds of different feeds that are going out, and they'll do a stereo 5.1 and 5.1.4 mix. And so there's too much really to be monitored by a human. So having some kind of audio QC, they do have some automated tools on the video, but they're pretty shaky in terms of what's going on the audio. But looking out kind of what the spatial distribution are, is there any glitches and things, and these are kind of things where I think AI's got a really big part to play, and where we would like to play that part coming up. Things like metadata, so describing what's going on the field of play. There's a lot of money spent in different sensors around, trying to find out when and where certain events happened. Well, actually, we know a lot of that information from the audio as well. And we did a project recently with FIFA looking at detecting when and where a referee's whistle was blown, so they know exactly at what point did the match actually start officially. When was the ball officially out of play? And that can help with adjudication and other elements of their workflow. So again, it's not sound mixing, but it's using the audio devices that are available to add a little bit more value so that the audio punches above its weight. And we talked a bit about enhancing sounds. Well, actually, that's really great application of what we've done as well. So when the ball's in the center of the pitch, our algorithm knows that ball was kicked there, but maybe it's coming through really quiet in the mix because there's so much crowd and some of the distance attenuation has filtered out a lot of the top end, so you can barely hear it. But actually, if you know all of the characteristics about the kick, then you can trigger a sample of that kick, and that's something that is built into our software as well. Obviously, noise reduction is a big one, and particularly in the US, one of the huge problems is managing the PA. So if you've ever seen an NBA game, but the PA is significant presence in the room on every single microphone feed. And so we're working with those guys to help clean that up, so it gives the audio engineer control back again over their production. One that I'm pumped about at the moment is auto highlight generation. So the highlights are obviously the things that the audience think are the most interesting and most engaging parts of a game. But typically it's one person who's not even at the stadium who's making that decision and kind of scrolling through and going, oh, that looked like an interesting bit. But wouldn't it be better if you asked the collective opinion of the 50,000 fans who are actually at the event, like which bits were most important? And so using the crowd microphones and doing a sentiment analysis allows you to say, oh, this is when they're excited, this is when they were angry and booing, this is when they were singing, chanting, clapping, those kind of things, all from the audio data. And then you can put together a graph of these are the most audience engaging moments of this game, and then you can segment that up into sections that are appropriate, and then you could compile some bespoke highlights on the fly. So that's quite cool. Or triggering graphics. Like, I'm not into this kind of stuff, but you can imagine the referee whistle sponsored by Coca-Cola. Every time he blows his whistle, he'd flag up a little Coke symbol or something. Probably like that in different territories around the world. Obviously, speech to text is something that we all know a lot about, but there's a lot of speech going on, whether it's the producer, whether it's the commentator, or other microphones that you've got around, and that just adds more metadata to help us kind of interpret what's going on and then automate different elements. Automatic language detection is something that we built into was actually running in beta version of our software, because when I'll talk about it in a minute, but we were out in Qatar for the World Cup, and we were managing 70 plus different commentary feeds. And if you listen to each one of them, you've got absolutely no idea, unless you're particularly gifted on like being able to discern the subtle nuances between like Bulgarian and Russian or something like that. And so having something that can automatically tell you which language that is and say, oh, by the way, the thing that you're sending out as Spanish is actually Portuguese, you might want to swap those feeds around. So that's quite a useful one as well. Up and down mixing are another thing which I think AI could have a big part to play. So taking your stereo, up mixing it to 5.1 and then up mixing it to a 5.1.4 Atmos presentation. At the moment, it's very static. It's kind of, there are set rules that are applied to that and it goes out. But actually, it's quite content specific as to how you would want that workflow to work and what would be the optimal parameters. And like I say, it's a dynamic thing, and that goes for up and down mixing actually. So that's cool. And then we had a student from the computer science department working on something for us earlier on in the year, which was on predictive mixing, which is quite fun. So we took a load of the TrackAb information, the TrackAb tracking data from the whole of the World Cup and some other tournaments from FIFA. So this is all of the players tracked over the course of the game, and the ball tracked as well. We took all of that and we trained an LSTM neural network to learn how play evolved around the field, so we could predict where it was going to be next. And we did it because it sounded fun and just thought it'd be a good idea. But part of the reason was so that we could have a look ahead audio mixer, so we could say, oh, most likely it's going to be microphone 5 next. So let's really listen into that microphone, and it's definitely not going to be microphone 9. So we can just bin that out and save ourselves some processing. But actually works surprisingly well. So we need to follow that up and actually implement it, because it was only running in a sort of a Python test environment at the moment. But some cool stuff. So this is our software that runs it, just to prove that this isn't just conceptual, it actually like exists in real life. So it's hopefully very user friendly. People tend to like it. It's kind of a drag and drop kind of vibe. So you define all your inputs up in the top left, and then have I got a laser thing? Yes. These are submixers that you apportion. So that's a pitch submixer, and this is the GUI for it here, because it's selected, it jumps up on the right. There's a crowd submixer, so that manages the up and down mix of different crowd flavors, taking like a B format and making an immersive representation. If we do a voice activity detector on the commentary, so that we can mix the level of the speaker rather than the level of the microphone, so that we can get a very even balance between the crowd commentary and the pitch effects. So we've got this very deterministic mix. Once you've defined those, we've obviously got the ice hockey and some horse racing and some other bits and pieces that we do as well. Once you've defined those submixers there, you basically drag them into these boxes, and you can define as many of those as you want. Those are the output groups. So you could have a stereo version, you could have a 5.1 version and a 5.1.4 version, and all you just do is drag and drop the components that you want to go out in that mix, and it will do lots of stuff, and it does the loudness to make sure that you're not breaking the rules of Ofcom and people as well. You can put VST plugins. It does a lot of stuff. In particular, Max has worked really hard and pulled a blinder. So that's our MIXaiR software that does it. How are we doing? Good. So I alluded to, well, I didn't allude to it, I literally said it. We went to World Cup out in Qatar with HBS, who managed the world broadcast feed. And we did some cool stuff, which I'm proud of, so I'll just shout about it. We're managing all of the commentary feeds that were coming in from around the world. So I was saying it was about over 70, I think we had. And we were mixing the commentary onto the international sound. So we were taking the mix from the match truck, the international clean effects feed it's called, and putting the commentary on top. So we're able to, we didn't actually do 70 of those mixes, but we were able to send out 70 different mixes if any of the broadcasters wanted access to those feeds. And we were also doing, this is a bit more boring, but we did it, so I'll say it. We did all the archiving for FIFA. So when you see like the highlights or whatever, all of the audio was recorded through MIXaiR. So we recorded every single microphone feed that was at every single game and all the commentaries and everything. So that was available for FIFA for archiving. And we even made them a little tool to, like, whilst we were there, so that they could actually cut up. They didn't really know about time code and stuff like this. So our software does all the recording with a timestamp, the broadcast WAV. So you can say, "Oh, give me the time, 5:30 to 5:32," and it'll chop out 2 minutes of audio for you. So we developed a little app to help them do that. We also did a automatic latency offset. So really simple actually for the guys in this room, but they were really impressed with it, so that's good for me. And it was just a cross correlation between two feeds to detect the latency between them. So they were sending the commentary, some of the commentary came straight from the venue to us, but the international feed goes via the master control room and then to us. So it's got a much longer round trip, so there's always latency offset between those. But depending on which encoders everything goes through, changes very slightly what that latency is. And so what they would do is they would put a clip through both lines and listen to one in each ear and kind of do a phase offset to see when it will just, like a phantom center, and they're like, that's the latency. But you can imagine that is quite a cool way of doing it, to be fair, but it was taking them ages to do it. So we developed like a latency determination thing, which even just worked off the background noise. So they're really pumped about that, because not only did they not need somebody with a clapperboard, but actually they could do it in real time, so you could even see if it drifted. So that was kind of cool. And we developed for them, one of the things we did was for press conferences. So at the end of the game, when they do the press conference, not everybody speaks English, but HBS are required to broadcast in English and maybe French and Arabic, I think. So there was always an unknown as to whether there was a translator needed or not. And so historically, they've had someone there riding the faders, and when the translator comes on, they push the translator up and they pull down the native speaker. So we did, using a voice activity detector, we automated that, so they didn't have to have somebody there the whole time, which was great, I think. It worked absolutely amazingly, apart from after the final, when I was sat until about 1 o'clock in the morning waiting for the Argentinians to come do a press conference so I could start everything off. And they never appeared because they're probably out freezing or something. I just sat in a darkened room on my own. But that's the way it goes. I talked about the language detection. And then lastly, we did some cool stuff. So I don't know if you've read in the news, but in Qatar was the first time they'd ever had a sensor in the ball. And so we managed to get access to the data from the ball, which was cool, via an IP link. And we developed a sample triggering engine using that. So in the ball had an accelerometer, and a gyroscope, and some kind of location tracking thing that I don't know about. And so we knew where the ball was and the rotation data and the accelerometer. So we used the rotation data to tell when the ball had been kicked or where it had hit a transition, because the rotation state changes, obviously, if the ball bounces or if it hits a foot. And then we used the accelerometer data to decide how big that impact was. And then that, for some reason, the gyroscope data worked a lot better for detecting the kick than the accelerometer data. Don't really know why, they just did. And then we would trigger a sample, which was actually recorded me in the park, kicking the ball, featuring on the World Cup final. There you go. And it sounded absolutely amazing. So all those, like every single kick could then have a ball moment, like the sound of a ball attached to it that was appropriately scaled, and it gave the sound engineer the ability to just gradually, you know, put as much or as little of that kind of augmented audio into the mix as they wanted. And it sounded amazing, and it was going to be used, but then it turns out the data from the ball tracking actually arrives 200 milliseconds after it's actually happened. So it's too late, which was really frustrating. It's because they were doing a lot of data processing themselves, and we needed to get the low latency version, which they do have, but they weren't prepared to unplug it and replug it in for us. So next World Cup, you'll hear me kicking the ball in Birchfield Park, hopefully. And so yes, that was about sort of like data follow audio rather than audio follow video sort of thing, which is used a lot. So that's pretty much us done. Just to conclude, I guess that AI seems like this magic black box of wonder, and it's, especially at the moment, reeled out a lot as the panacea of everything. But I guess the takeaway is it's really difficult. There's lots of actual challenges associated with that. One of them would be tagging the data accurately, like Max was saying, figuring out what content pre-processor, because it's not really a one-size-fits-all kind of approach. Optimizing a network is an absolute pain in the bum and is, in my opinion, really difficult. Figuring out what's the right tool for the right job, because we've discovered that some things work really great when you apply machine learning to it. Some things actually you don't need machine learning and you're wasting your time applying that to it, and you'd be better off just using kind of dynamic thresholding of like a normal algorithm. And thinking about what elements should be automated and what elements should be left to the creative endeavors of the sound supervisor, so you don't annoy people too much, or, you know, to solve a problem that doesn't exist. Everybody always criticizes me for trying to take people's jobs, so I always have to put that in. Like, there's a skills shortage in the industry, so you've got to pick a lane. You're saying there is too many jobs or there's not enough jobs. But either way, I feel like we're making assistive tools that make life easier and allow people to do more things with less kind of annoying overhead and less kind of requirements on their time, because the amount that we're expecting sound supervisors to do is only ever going up, and the amount of niche sports that is desired to be produced is only ever going up. So we do need some assistive tools. Biggest challenge though is there's just too many cool things to do, and I want to do them all. So I think that's us done. Back screen.